Welcome back to our discussion about solving polynomial equations. And in this video, we are going to focus on how can we use the factor theorem to solve a polynomial equation. All right, so let's talk about that. To really discuss the factor theorem, we need to go back to this equation that we got when we were talking about the remainder theorem, right? We got this by thinking about f of x divided by x minus c would equal a polynomial q of x plus r over x minus c, and then we multiplied through that x minus c to get this, okay? So if I go back to this, and then I remember the result of the remainder theorem, which said that the remainder from this polynomial division relationship will always equal f of c. Okay, and so I can replace the r here with f of c. Okay, so that means that the function f of x would be the same as the quotient times the divisor plus f of c, the remainder, okay? Now, what if we said f of c is equal to 0? Okay. If f of c is equal to 0, then that last piece just drops off, right? There's no remainder, okay? And then what if we go one step further and evaluate f of c? Okay, so then f of c would be c minus c times q of c, which is just 0 times q of c. And that would just end up being 0. So what does all that mean? Okay, what that means is if f of c is equal to 0, that implies that x minus c is a factor of f of x. Okay, and that's what the factor theorem states. F of c is equal to 0 if and only if x minus c is a factor of f of x. And that if and only if statement means that if this first piece is true, then the second piece must be true, and vice versa. If the second piece is true, then that first piece must be true. Okay, so how can we use that? All right, well, it seems almost like it's common sense, right? But we can actually use this when we are trying to solve polynomial equations, and this is kind of our segue into that actual solving piece. If I am interested in solving 2x cubed minus 5x squared plus x plus 2 is equal to 0, and I know that 2 is a 0 of the function f of x to it. F of x is equal to 2x cubed minus 5x squared plus x plus 2. That means that when I divide the function by x minus 2, I should get a remainder of 0. What that does for us is it allows us to break down this cubic function into a linear piece and a quadratic piece. The linear piece is going to be the divisor, x minus 2. And then when we divide that through, we will find the quadratic piece. So let's do that. Okay, let's start by dividing through, let's divide out x minus 2. And we'll use synthetic division with 2 as our entity in the box. Okay, remember checking and making sure that our polynomial's in standard form and we're not missing any pieces. We can just pull the coefficients. Great. Bring down that first coefficient 2, multiply it by the value in the box, which is 2. We get 4. Add that to the negative 5, gives us negative 1. Negative 1 times positive 2 is negative 2. Add that to the 1, we have negative 1. Multiply that by 2, we get -2. And when we add that together, we get 0. Okay, and we fully anticipated that we would get 0, right? From that factor theorem, we knew that if 2 is a 0, then I would get a remainder of 0. Okay, that's great, because what that allows us to do is take that equation that we started with and break it into factors. We said that this implies a factor of x minus 2. There it is. And then what these coefficients give us are the coefficients of the quadratic, because this is a remainder, our constant, and our x term, and our x squared term. So this is what we are left with. Okay, well, what that does for us, by breaking that into those two pieces, we can solve this equation because we know how to solve linear equations and we know how to solve quadratic equations. Fabulous. Now you can take this quadratic equation and solve it by either the quadratic formula or factoring, whichever you prefer. I definitely prefer factoring because to me that's the fastest. And so when I factor this completely, this 2x squared minus x minus 1 factors into 2x plus 1 times x minus 1. And when I factor this completely and set each of my factors equal to 0, I get my solution, 2, -1/2, and +1. Okay, and you can go ahead and check and make sure that those work by taking these values and subbing them into that equation. All right, so that's how you're going to use a factor theorem to solve a polynomial equation. And in our next video, we are going to talk about, okay then, let's just solve a polynomial equation without a 0 given to us. And so that's where we'll pick up next. I'll see you then.